Hello, welcome to our channel for probability and statistics. In this video, we will talk about chi-square distribution. Chi-square distribution is a continuous distribution with degrees of freedom. It is most widely used to describe the distribution of a sum of squared random variables. That's why the name called chi-square. It is also used to test the goodness of fit of a distribution of data, whether data series are independent. And chi-square distribution also used for estimating the confidence interval surrounding the variance. So if C1, C2, Cn are independent standard normal random variables with 0, mean, and standard deviation 1. So the random variable x, which equals the sum of C1 square plus C2 square until Cn square, so this variate follows a chi-square distribution with n degrees of freedom, where n is the number of n C1 to Cn. Here, n variables square summation, where C1, C2, Cn are normally standard normal distribution variable. So chi-square distribution usually has the notation with chi-n squared. So this figure shows several chi-square distribution density curve with different degrees of freedom. In regression, we know the sum of squared residue divided by the variables observations variance has a chi-square distribution with n-1 degrees of freedom, where n is the number of observations in the data set. And if we do independent tests of two categorical variables, the test statistic, which is this one, follows a chi-square distribution with r-1 times c-1 degrees of freedom. So r and c are the contingency table between two variables. So r is a row number, c is a column number. And this statistic calculation is observed counts minus model counts, take square divided by model counts, and take sigma for all items in the contingency table. So chi-square distribution actually is a special case of gamma distribution. So we know gamma distribution has two parameters, alpha, beta. It models the time between Poisson process event, right? So gamma distribution has density function like this one here, where gamma is the gamma function, gamma alpha times beta alpha in power, then when divided by these terms, then times x alpha minus 1 in power times e minus x divided by beta in power for the positive variable, where alpha and beta are positive numbers. When alpha equals v divided by 2 and beta equals 2, so gamma random variable becomes a chi-square random variable with the following density function. And here we call v is the degrees of freedom. It's a positive integer. The mean and variance of the chi-square distribution is mean equals v, where is the degrees of freedom of chi-square distribution, and variance is 2v. So we can use chi-square distributions probability table to do some tests. So here chi-square is the random variable, positive random variable, and alpha is the right side of this variable represents the probability that random variable, chi-square random variable larger than this number. And from this table you can find from the left column degrees of freedom and alpha, this shaded area, and chi-square value. So for example, for degrees of freedom 5, for the variable 7.289, is this number, get 0.20 for the alpha. So this shaded area probability is 0.2. So we take a look at two examples. The first example, determine probability of chi-square degree with chi-square random variable with degrees of freedom 26 less than or equal to 30. The solution is check the table for variable 30. So we find the variable 30 in the table, and the degrees of freedom 26, we get alpha is 0.27. Because alpha represents the probability of chi-square variable larger than 30, right? So, which means chi-square variable here less than 30 is 1 minus alpha, is about 0.73. And example 2, find the chi-square variable with alpha equals 0.05 and degrees of freedom 15. So check the table. For alpha is 0.05 and degrees of freedom 15, we can get chi-squared variable number is 24.1996. Thanks for watching.